So today's lesson, we're going to look at the human fossil record. So far, we've looked at the evolutionary uh, evolutionary history of Homo sapiens, going all the way back from mammals coming into hominins. And in our last lesson, we looked at how different hominins emerged throughout our evolutionary history and how we are related to each and every one of them. Today, we're going to basically find out how is it we can make assumptions based on fossils that we obtained. And also a key point that you're going to realize from today's lesson is that we don't actually know a lot about this, about our evolutionary relationship, evolutionary path, due to the fact that the fossil records that we have are incomplete and also inconclusive. So essentially, it lends itself up to a lot of interpretation due to the fact that it's incomplete and we can't exactly get a clear picture of what's happening due to a few factors. Most importantly, being that fossilization is a very hard process. So there's a lot of things that we're going to be looking at. All right. Before that, let's look at the question. Which sequence best shows the order from the most ancient fossil skull to the most modern fossil skull? It should be very straightforward. Everyone have an answer? Yeah, let me go grab the ball. It's set. Yes. All right, so let's have a think about this as quickly as you can. Try to answer it. Which one is the oldest going to the most recent, right? So can I have a look at everyone's answers? All right, so interesting. I see a divergence in the answers. Half of the class is saying one answer, the other half is saying another answer. The answer is D. All right, so going from the oldest to the more recent one. So one indication is that this is an Australopithecus skull. This is a ancestor before Australopithecus, and this is the modern hominoids that we are looking at, right? I know it can be a bit hard to tell. Certain characteristics you can look at is the size of the teeth, right? So even comparing the teeth between the Australopithecus versus the skull number one, you can see that the skull number one has much larger teeth as well. So that can be a key indicator of which one is the older one. All right, obviously this is more, skull 2 is more of a human skull, so that is the most recent one, right? Hopefully you guys get better at recognizing it over time. So today's lesson, we're going to focus on looking at the human fossil record as an example of the classification scheme, and notice how it is still open to differing interpretations and are contested, refined, or replaced when challenged with new evidence, including evidence of interbreeding between Homo sapiens and Homo neanderthals, and evidence of new putative Homo species, right? So basically what this is saying is that due to the fact that our evidence relating to hominin fossils is very incomplete and very fragmented. We don't really have a clear picture to basically outline a clear evolutionary relationship between the different hominins that we've discovered. All we can do is create interpretations based on what we have in terms of information about how old the fossils are, where they were found, and what other information we can find along with them. So that's why it is open to differing interpretations. And also, more importantly, it can change based on any new information we obtain. So imagine right now, today, there's a new fossil that's discovered in a cave somewhere that kind of disproves a lot of the information. Scientists will actually start to incorporate that new information into the current understanding by trying to find interpretations that allow that new evidence to be included, due to the fact that the information that we have is so incomplete that we need to be able to be open to interpretations to try to find a more suitable or more uh, accurate representation of our evolutionary past. So even looking at this right now, right, compared to how we used to think about just barely 20 years ago, how we used to think about, was it 20 years ago? Yeah, 20 years, 30 years ago almost. Wow. 30 years. Let's get out of it. It's almost 30. 30 years ago, the way we used to think of the evolutionary relationships of our recent ancestors and how we think of it now has changed massively due to the finding of new fossils, due to the finding of new evolutionary trends, and also more advanced techniques using molecular homology try to have a comparison of our different ancestors and trying to piece it together from one coherent evolutionary tree. So that's why it basically lends itself to different interpretations, and it's also very tentative because when there is new evidence that emerges, we need to basically try to accommodate it into our evolutionary tree, and then we have to try to interpret it in the right way. So there is room for interpretation. You guys will basically need to understand that this is the situation with our hominin evolutionary tree where it is still very tentative and not complete, right? We are still basically think of it like a 1,000-piece puzzle where we're missing about 500 pieces. We are still trying to piece things together and we don't have a complete picture of what we have so far. Right? We don't have a complete picture of everything that's happened. So why is it is this? Why is it we have a incomplete fossil record of hominins? Is basically the general reason of why any fossils are hard to obtain is because fossilization is an extremely rare event. The fact is, it does not always occur. There are specific conditions that need to be met for fossilization to occur, two of which are most important is that one, dead organisms need to be very quickly buried with sediment as soon as they have passed away, because as soon as they pass away, the two things that can happen is that they can be hunted by scavengers. These are your, what are those birds called again? Vultures, yeah. So scavengers like vultures, they will basically hunt for dead organisms. So if scavengers are able to get to the dead organism before they get buried in sediment, then fossilization will most likely not occur. In the same way that if it starts to decay before it gets buried by sediment, fossilization will also not occur. So these conditions need to be met. Also, even after it's been buried by sediment, it also needs to be buried in a way where the organic material will eventually be replaced with minerals in a process known as fossilization, right? So it falls under fossilization where those organic materials in the bones in our all those organic components of any living thing need to be replaced by minerals, and only then will it actually get preserved for a very long time. And this is not always going to happen, and it depends on where it occurs as well. Okay, in the right place to make sure that minerals can actually replace those organic materials. And like I said, not all conditions allow for this to happen as well. So if you go back to our lesson on fossil records, you will see the specific conditions that fossils need to have. One is also controlling the moisture, how much water it's exposed to. Another one is how much air is exposed to. These are all factors that are important and need to be met so that fossilization can occur. And I am highly advising you guys to really look this up, because in almost every exam there is something about fossilization that will come up, right? They will always bring up at least one question about why it's been hard for fossilization to occur, or why the bones are not being actively found, or why hominin records are incomplete. Something relating back to this question, where you're basically answering that fossilization is an extremely rare event and it requires conditions such as uh, sedimentation occurring at a very quickly after the dead organism has passed away, ensuring that it has a low exposure to oxygen and water, and also the fact that organic material needs to be replaced by minerals. So even so, sorry. Even if all these conditions are met, there are also other factors that can also cause hominin fossils not to be fully found. For example, there's also a case where when we find hominin fossils, we find incomplete fossils of a complete specimen, or we find complete fossils of an incomplete specimen. Basically, what that means is that we either find parts of a complete specimen, so we can find parts of fossils of one complete specimen, or we will find basically a complete fossil of an incomplete specimen, basically just one skull, but we can't find any other traces of it, or we'll find traces of a bunch of different fossils of one specimen, but they're all incomplete, they're all not well preserved, right? They're still very damaged. So we will always either find it in one or the other way. And the factors that can play into that is also the fact that rock layers within the fossil eroding and can disappear over time, meaning that the Earth is basically moving around, right? We got tectonic plates. That means that we have rock layers that have those fossils that can erode and disappear over time. They can also weather over time due to being exposed to the environment. Let's say the rock layers expose those fossils. If they get exposed to rain and weathering factors, they can also get lead to the loss of those fossils. Or something more human error related is inadequate excavation of the fossils can also lead to the loss of those fossils. Basically, people who aren't experts in their field trying to excavate different fossils sometimes can miss out on those fossils, or they can basically inadvertently destroy some of the fossils in the process without them even realizing it. Because it's not exactly something so easy to do, spotting fossils. They're not so easy that anyone can do it, and not every attempt can be successful in retrieving all the fossils. So that's some of the reasons why we have an incomplete fossil record of our hominin ancestors. So we are forced to use stuff like femurs and teeth to piece together a lot of our fossil records. So sometimes we might just find something as simple as just one teeth, and we extract as much information as we can from that one piece of evidence. So it is not uncommon for that kind of a occasion to happen. So what kind of issues can an incomplete fossil of specimens lead to? Essentially, what can this be? Why is this a problem? Why is having an incomplete fossil record a problem? Is because if we have an incomplete fossil record, it can be very hard for scientists to come to a consensus to agree whether a new fossil is a new species or whether it's a species we already are aware of or whether they are basically diverging from everything we know because they might share features with previous known fossils and that can actually cause confusion because remember when species are very closely related they will share features with each other and that can be an issue when we are trying to determine whether it's the same species or whether it's a different species in between them because we are still piecing things together so there's a lot of interpretation that can go into it so basically doing a lot of guesswork, trying to piece together a puzzle without knowing how big the puzzle is or knowing how many pieces are in the puzzle. So that's why there's a lot of interpretation that goes into it, right? And sometimes even molecular homology is not going to be an answer to this question because when we're thinking about fossils that have been basically around for many millions of years or thousands of years, not it can't exactly be molecular homology can't exactly be readily used to find information because DNA can be very hard and costly to extract from fossils. And it's also a very emerging field where we are learning how to try to extract DNA from fossils that have been found. So we have only painted a very general picture so far based on the information that we found. There are still new discoveries that basically have to be placed within this entire picture that we have found that we haven't been able to do accurately. And that lends itself to a lot of interpretation. And one of the examples of that is with your Homo naledi, the lady, however you want to pronounce it, this is not a pronunciation class. So this is a fossil that was found in 2013 in a cave in South America, Africa. And one thing we realized is that it resembles those of both, sorry, resembles both modern humans and also older hominins, which are your Australopithecus. So we thought possibly this could be a transitional fossil. Who can tell me what a transitional fossil is? Abi? So what's the feature of transitional fossils that they need to have to be considered a transitional fossil between the essentially they need to share they need to show traits that are common between its ancestral group and also the descendant group. That's why they're considered transitional because they form that link between the ancestral and the descendant, showing the transition happening. That's why they are considered as transitional fossils, right? They basically demonstrate the evolutionary change between the two different evolutionary steps, right? And when we looked at this fossil of Homo naledi, we found that they share these two different sets of features that are reminiscent of the old hominins and also the genus Homo, where they had primitive shoulders, they had fingers that are long and curved, suggesting that they were tree climbing. They had a wider pelvis, skull that is small, and a wide rib cage. So these are just put it on the side. So these are some traits that are apparent with your Australopithecus. And when we compare it with our genus of Homo, they also have a rounded skull shape. They had hands that are well suited for object manipulation. They had arched feet and smaller ankles. So they basically had the features for both the old hominin and also the current genus of Homo. So it was actually considered as a possible transitional fossil. So when they found this fossil, they didn't do one thing, which is they actually did not date the fossil when they found it, which is a big mistake to be considered because dating a fossil can actually help understand where or how old the fossil actually is. So that's why dating techniques are also used in line with structural morphology and also molecular homology, we need to be able to date them to have an understanding of when they were around as well. So when these fossils were found and we were seeing these common traits between the two different genuses, we were thinking maybe they existed as a transitional fossil somewhere around the time that there's a transition between Australopithecus and Homo erectus, right? So there were three different outcomes that we hypothesized when it came to these the Homo naledi and where they could have existed, when they could have existed. The first one suggested that, let me show you guys. So the first one suggested that if they were existed around the time that Australopithecus were around as well, it would suggest an earlier divergence between Australopithecus and Homo, and this would mean that Australopithecus afarensis was our evolutionary cousin rather than our direct ancestor. However, this was a very unlikely outcome due to certain things that we were able to find as well, because one of the information that was also important to consider is also the fact that how they were buried. When these bones were found, it was found in a burial site. Basically, the area around the fossil was indicated that it was an actual burial site, which indicates customs of burials that are more in line with more recent species of Homo, right? Not something that existed around the time of Australopithecus, but basically something that existed around the time that genus Homo was thriving. So let me try to explain this in a better way. Our custom of burying our dead is something that we've been doing for a very long time. So if we trace it back, it was something that started around the time of Homo erectus to Homo neanderthals and so on. So this is actually a custom that we've continued up until today, right? But when we found this Homo naledi, we found that they also were carrying out these customs. And remember that customs are a cultural evolutionary thing, something that you pass on to the generations. So the fact that we found this fossil in a burial site indicates that it is a custom that was passed on as well. So we were thinking that it had to be, it indicated that either if the Homo naledi appeared very early on, that means they already started doing a custom super early on, and that was unlikely because we couldn't find any evidence to support that. So we thought maybe it could be this, right? Maybe it could be outcome two, where if they were dated around 2.5 to 2 million years ago, it would match anatomical evidence. Basically, the fact that both of them, this fossil shared features with Australopithecus and also the genus Homo, that would be explained by putting them at the time where Australopithecus were diverging from the genus Homo, and it would explain it as a transitional fossil. But when we actually got the last piece of the puzzle, which is when we actually dated the fossil, we found that it was actually dated to around only 250,000 years ago, where it matched up with outcome three, where they were basically living alongside Homo sapiens as well. And the fact that they shared features with Australopithecus does not indicate any transitional fossil. Rather, it's just a artifact of the previous evolutionary relationships we had with them. So this is what I mean when I say there's a lot of interpretation that goes into it, right? If we don't have the full picture, if we don't have all the information, we might even have placed them in a different timeline, right? So that's why it is important to consider all the information that we have and try to get more information on that as well. So we needed information about its age, about its features, about its molecular homology, about anything we can derive, basically even its burial site, whether it had tools, whether it was buried with anything. whether it was actually buried under a burial site or whether it was just left as it is. These are all information that we can use to actually interpret where it could have actually ended up within the evolutionary relationship tree. So only then can we make a conclusion. And even this is not a foolproof conclusion because we also still need to get more evidence to be more sure about this, right? So, like I said, always remember when it comes to the fossil records of the genus Homo or any other fossils that we find, we will need to take into account that there can be interpretations that are incorrect, that need to be changed over time. So nothing we know can be, nothing can be said for certain. We still need to basically piece together the puzzle, and we can only say for certain things that we know. For example, when it comes to Homo erectus, Homo neanderthals, Homo habilis, Australopithecus, because these are fossils that we found in a lot of volume, and we've also been able to get a lot of evidence to support the evolutionary relationships that we share with them. But any new fossils that we find, we still need to piece together how it comes into the grander scale picture that we have here. All right. So far we've talked about how the fossil records are going to change based on new information. But let's look at something that also changed our understanding based on molecular homology, right? So molecular homology gave access to looking at the DNA of different species and trying to compare them to see any evolutionary relationships. And that's when we realized one piece of evidence that we didn't consider before. The fact that there has been interbreeding happening between Homo sapiens that specifically had just migrated out of Africa and also Homo neanderthals that were basically around Europe or Australasia. What happened was that there was an interbreeding event. What does an interbreeding event means? That there was reproduction occurring between the two different species and to produce a viable offspring that actually carried forward all the way until today. And the reason why we know that it happened specifically with Homo sapiens that had just migrated out of Africa is we'll be discussing that as well. So let's talk about Homo neanderthals very shortly first before we get into the evidence for interbreeding. Basically, Homo neanderthals are our close evolutionary cousins that were basically around Europe and Asia around 40,000 to 400,000 years ago. And when we compared their mitochondrial DNA, we were able to find that we shared a common ancestor about 400,000 years ago. Basically, that is when we diverged from our common ancestor to become into Homo sapiens and also Homo neanderthals, right? So our last common ancestor was 400,000 years ago. But since that divergence, we actually also overlapped and interbreeding happened where DNA studies of the two populations, the two DNA studies of the two different species shows that 1 to 4% of modern Homo sapien DNA actually is identical to Neanderthal DNA. And this was specifically found in populations that migrated out of Africa. So if we actually went back to Africa and sequenced the DNA of people who didn't migrate out or people who weren't descendants of other populations, and we specifically look at those who stayed in Africa, we find that they don't have this Neanderthal DNA inside their genome because they never interbred with the Homo neanderthals that were in Europe. Only specifically those Homo sapiens that migrated out of Africa and went into Europe had overlap with Homo neanderthals, and then there was an interbreeding event that occurred. As a result, we can conclude that Neanderthals may have interbred with humans as they left Africa somewhere in the Middle East around 65,000 years ago and did not interbreed with African humans. Okay, we have enough evidence to actually state that inference very clearly. And another piece of evidence that also shows that an interbreeding event happened was that about 100,000 years ago, 100,000-year-old DNA from Neanderthal fossils found in Siberia contain a significant amount of ancient Homo sapien DNA inside it as well, which indicated there was a second interbreeding event that happened with humans. Right? There are already humans before. Yeah. So Neanderthals are Homo. They're under the genus Homo, and they're one of our most closely related from the genus Homo. So whether you consider them as being humans or not, that's a very different case. Oh, Homo sapiens, yeah, we existed for about 200,000 years ago itself. So the first Homo sapiens that migrated out of Africa, I'm not sure when they migrated. We'll actually look at that in the next topic. But Homo sapiens were found to have already emerged from Africa at about 200 to 250,000 years ago. So that's how old Homo sapiens as a species were. But this interbreeding event that happened with Homo neanderthals only happened about 65,000 years ago. So Homo sapiens emerged in Africa, and when we started to migrate out to different regions of the earth, one of the places we migrated out to was in Middle East or Europe, somewhere around there. And this interbreeding event happened because there were two different populations of the genus Homo in the same place, right? Homo neanderthals existed and also Homo sapiens existed at the same time in the same place. And as a result, interbreeding happened. And yeah, we have even DNA evidence to indicate that that is something that actually happened back then. And this isn't just something that happened once, actually was evidence to have happened another time, even in Siberia, where we found a fossil of a Homo neanderthal that also had a significant amount of Homo sapien DNA inside them. Any questions? So basically think of it like this, right? You know how there's different types of tigers? So there's a Bengal tiger, there's what other tigers are there? I don't know. There's a lot of different breeds of tigers, right? Imagine if we put a bunch of those different tigers together, that there will be interbreeding events happening because they are very closely related to each other, where they can produce a possible viable offspring, and that could be, present in the future as well. The same thing happened with the genus Homo, where Homo neanderthals are so closely related to us that they can actually they could actually produce a viable, fertile offspring that is evidenced in the DNA studies that we can do today. Okay. Apparently we're running out of time when it comes to Zoom. 6 minutes. Let's see if we can finish in 6 minutes. Okay. So how can we tell Homo neanderthals and Homo sapiens apart? Basically, our features are different, where Homo neanderthals have a wider nose, a shorter limbs. You can see the difference in the limbs. A stockier build. They're a bit more stockier, meaning like buffer, if you want to say that. A flat rib cage, a sloping forehead, an enlarged brow ridge. So that's something that's pretty obvious. Compared to Homo sapiens, the brow ridge of Homo neanderthals is much more prevalent, right? Which you can see in the skulls themselves. You can see that Homo sapiens, our brow ridge is less pronounced, whereas a Homo neanderthal's brow ridge is much more pronounced. And funny enough, Homo neanderthals actually had a larger cranial capacity. meaning some people have actually theorized that Homo neanderthals might have had a bigger brain than Homo sapiens. But since we can only find the cranial capacity and we can't exactly tell whether it's directly related to brain size or not, we can't exactly conclude that they had a bigger brain or anything. They also had a better resistance to colder climate, and you might be able to attribute that to their stockier build as well. So why is it we say that, not why, but like more, how is it that 1 to 4% of or Homo neanderthal DNA exists within any Homo sapiens that emerged out of Europe exists? Basically, if you're not from a direct descendant of someone from Africa, you basically have Homo neanderthal DNA inside your genome. How does that exist within your genome? It's not like everyone has the same exact copy of Homo neanderthal DNA within their genome. In fact, it can actually vary. Some people might have segment A of a Homo neanderthal genome, some people might have segment B, some people might have segment C, and so on. So it's so very it can vary so much that by doing a study of about 2,500 people, a study was done with 2,500 individuals where they pieced together all the segments of different Homo neanderthal DNA from each person. They were basically able to build up 40% of the Neanderthal genome using these different segments from each different person, where we were able to find 40%, but the others were still remaining. And there is no telling what we can actually do if we keep doing it with every human being. We might actually be able to sequence all of the Homo neanderthal DNA. But this study that was done was just done with a small sample size. So even with a small sample size of 2,500, we were able to piece together about almost 40% of the Neanderthal DNA. So there's a lot of variation of the segment of Homo neanderthal DNA that each person has. And by putting them all together, we can actually possibly build back the entire Homo neanderthal DNA sequence. All right, now to get through. So, as a result of the fact that we need clearer evidence to be able to place different Homo species in the evolutionary tree, we still have different fossils of different species of Homo that we haven't really pieced together or really haven't uh, put into the grander evolutionary tree, like Homo denisova and also Homo lusonensis. Okay, both of which were more recently found, where Homo denisova were found about only in 2010. And when we dated them, we found them to be about 40,000 years old, and they were more closely related to Homo neanderthals. But one thing that we also found was that even with these Homo denisovas, they had an interbreeding event with Homo sapiens as well. Specifically, Homo sapiens in a very specific region called Melanesia, which includes Fiji, Vanuatu, Solomon Islands, and also Papua New Guinea. How were we able to inference this? Is because when we sequence the DNA of Homo sapiens from that region, we find that 4 to 6% of the DNA is shared with the Denisovans. And this interbreeding event likely happened anywhere from 15,000 to 44,000 years ago. So there were two different interbreeding events that occurred with Homo sapiens and different species of Homo. One is with Homo neanderthals, and the other one is Homo denisova, and each of which ended up with a certain percentage of DNA being shared to the descendants, right? With the Homo neanderthals, it's about 2 to 3%, 1 to 4% of the human genome of most humans around the world, and other than those from us, African descendant, will share that 1 to 4%. But specifically, if we went to the region of Melanesia, we'll find that even 4 to 6% of their DNA is made up of, is shared with Homo denisova, due to another interbreeding event. So there is these two interbreeding events that we found that have influenced the DNA sequence of modern Homo sapiens until today, based on these different species. And then the second one is your Homo lucenensis. This is where basically they both have an unexpected mix of both modern, ancient and more modern hominin traits, making it difficult to basically identify the bones as belonging to an existing species. So this one, there's no interbreeding event. It's just something that basically presents itself as a question of where or when they could have actually existed. When we dated them, we found them to have been 67,000 years ago old.